Hi, welcome to Learning Monkey. I am Vikram. In this class, we'll try to understand classless inter-domain routing. The concept of classful addressing has already been discussed in our previous videos. If you haven't watched those videos, please watch those videos and come back here. And every video in our channel is going to be part of entire course or a playlist. Our suggestion is to follow the entire course so that you can have better understanding of the concepts. The link for the playlist is provided in the description below. Now coming to this class, what is classless inter-domain routing? So far in our previous classes, we have covered classful addressing. There we have seen that the entire group of IP addresses are divided into 5 classes: class A, class B, class C, class D. But there are lots of disadvantages with that classful addressing. One of the most important disadvantages is, for example, with the classful addressing, for example, if you want to create a network with 300 systems, 300 systems means either, so with the 300, if you want to create a network with 300 systems, you should have the possibilities. So class B addressing is going to have a capacity of 256. Class C addressing is having a capacity of 256 systems. If you consider class B address is having a capacity of 65,000 systems. Now with 300 systems, to establish a network with 300 systems, we should not opt for class C system, class C address mechanism, class C address. We have to go for class B addressing mechanism, which means all the remaining IP addresses are of no use, they are of waste. Okay, so this is one of the major disadvantages that we have with classful addressing. So to address the disadvantage, we have another mechanism called classless inter-domain routing mechanism, and this is the mechanism that is being used at these days. So in 1998 or 1997, the classful addressing mechanism has been stopped. So coming back to the classless CIDR, classless inter-domain routing. So this CIDR, so before understanding the overall view of the CIDR, let's try to understand what this IANA. IANA stands for Internet Assigned Numbers Authority. So this is the authority where all the IP addresses, 2 power 32 possible IP addresses, are controlled by this authority. So they are going to assign the IP addresses to this entire world. Okay, so now let's visualize the things in a different way. So far, class A, class B, class C, no more classes. Now the entire 2 power 32 IP addresses are grouped into one or in one single group, and each line here is representing one IP address. So it is going to start from 0.0.0 to 255.255.255.255, means all these 2 power 32 IP address, each line is representing one single IP address. See here, this line is 0.0.0.1, 0.0.0.2, 0.0.0.3. So in the same way, all these 2 power 32 IP addresses are there in this group. Okay, so now how the CIDR addressing will be. So the representation of CIDR is done in this way. It is, as we don't have any classes, so this is how the CIDR represents class. CIDR IP address is represented. It is w.x.y.z/n. This n stands for bits for network ID, number of bits that are assigned for network ID. It is represented here in this way, /n. Let's take an IP address and we will think of that, and later we will try to understand how the IP addresses are allocated. Okay, so let's take a sample example. We'll take the previous example that we are taking in the previous videos. It is 194.24.2. Let's assume that it is 194.2.67/26. So what it represents is the first 26 bits are represented for network ID, and the remaining 6 bits are represented for host ID. Okay, so let's take this. So here 192.24.2.67/26 means these first 8 bits dot, these first bit 8 bits are also network part, this 8 bits are also network part for this octet, and for this, in this octet only 2 bits will be for network parts. Here 8 plus 8 plus 8, 24 plus 2, 26 bits, and the remaining 6 bits will be allocated for host ID. Okay, this is one of the IP address. This is just one IP address. In this way the representation is done. Okay, so we'll go deeper how these IP addresses will get allocated. For example, so one of the rule is you should always ask for powers of 2 IP addresses. For example, if you want to construct a network with 70 systems, you should not ask for 70 systems. How we should ask for is, I want 128 addresses, because 64 next to 2 power 6 is 64. With 64 IP addresses we cannot construct a network with 70 systems. Now we have to go for the next level. It is 2 power 7. 2 power 7 means it is 128. So we should ask for 128 systems. Okay, so with that 128 systems we can construct a network with 70 systems capacity. Okay, so now I want to construct a network with I want 64 IP addresses. Now how that INA will give is, so it is going to take a piece of cake. Visualize this as a one single cake. In this one single cake they will give you pieces. They will cut them equally and they will give you those pieces. Okay, so not equally, they will cut them in a clear shape, and that piece of cake will only be provided to you. For example, if you want a network with 64 IP addresses, assume that these are the 64 IP addresses, only this piece of cake will be provided to you. Is it the only possibility for 64 systems? No. So this is another possibility. The next 64 IP addresses is also another possibility, right? With 64, this point is very important to understand. This is the point that you have to understand. So is it the only possibility to get 64 systems from this group of 2 power 32 systems? No. Any IP address you can get, either this also, from here to here. Assume that in between there are 64 systems, so this piece of cake is also possibility. And similarly, if you take this piece of cake, so here assume that these are 64 systems. This is also another possibility, and this is also another possibility. This is also another possibility. You may get any one of these possibilities. Try to understand this with IP addresses. We'll try to understand this with IP addresses. So let's consider 2 possibilities. So we will take 2 possibilities. One is 190. So I think you have that visualization of that cake. Okay, it is 194.24.2. And this remaining 6 IP addresses, in this 8 is there, 8 bits are there. So now with this 194.24.2, what are the combinations that are possible? So there are 4 combinations possible. It is 00, 01, 10 or 11. So we will go very slowly. With 00 means what can be the IP address? The IP addresses range, I am talking about the piece of cake. This is one piece of cake, this is another piece of cake, and this is another piece of cake, and this is another piece of cake that is possible with 194.24.2. Okay, so if you want to get from this piece of cake, these are the possibilities. It is again four piece of cakes are possible from this part of IP address. So let's try to visualize this. It is 194.24.2.00 is also used for network. I am stating that this is /26. Keep that in mind. So the 26 bits will be addressed for network. 8 bits, 8 bits, 8 bits, 24 bits plus 2. If it is 00, then the possibility is the remaining 6 bits. Okay, it is from 00000 to all ones. All ones. Okay, so the range of possibility is, it is from 0 to 63, and the first IP address is going to be your network ID. If this is the piece of cake, if this is the piece of cake that we are going to get, so the network range, the IP addresses that are possible is 194.24.2.0 to 194.24.2 to 2.63. And in the same way that we have discussed in the classful addressing, the first IP address is going to be the network ID, and the last is going to be the directed broadcast address, and in between 1 to 62 IP addresses are the host IP addresses. This is one cake, one piece of cake. So the other possibility with this part is used as the network part is, the other possibility is 194.24. This is another possibility, another piece of cake that may be given to you. Try to get that point. I am stressing it again. Okay, so it is 01, and the remaining 6 bits are for host IDs. It is 0000002 all ones. It is all ones, 6 bits. So it is now this range 01 to 01. What is this range? It is from 64 to 127. 64 to 127. If you take 128, the third piece of cake that we are going to get. So the code is going to be 10. This is one piece of cake, or this is one piece of cake. You may get any one of the possibilities. So all I need to make you understand. So I am stressing it again and again because there are millions of possibilities. You may get any one of that cake. Okay. Try to get that point. It may be, for example, it may be 20.30.6.0 to 63. This is also possible. You may get this also. There is no class. It is classless. So 256 system means it is not going to be, we are not going to decide that it is going to be a classless addressing. It is going to be a class C address. No, there are no such classes. You may get, there are millions of possibilities. You are going to get one piece of cake. Okay, so this is also a possibility. 20.30.6.0 to 63 is a possibility. 0 to 63 is a possibility, and the other possibility with this piece of cake is means 20.30.6.64 to 127. This is another possibility. You may get this one or this one. So this is how the classless inter-domain routing is. Okay, hope you got the clarity on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this concept, please post your doubt in the comment section below. And if you feel that this video is helpful to you, please give us a like symbol and please share this video with your friends so that they will also get benefited. Thanks for watching.